Welcome to our channel Sankalp Study Success. In this video, we are going to learn about identities of regular expression. We are going to have some of the identities which we need to remember, and also by using these identities, we are going to prove some of the regular expressions. So now, let us see what are those identities. Here, these are some of the identities which you need to remember, where epsilon r is equals to r epsilon equals to r, epsilon asterisk is equals to epsilon again, and phi asterisk is also epsilon here. Epsilon asterisk and phi asterisk are epsilon. Then phi r is equals to r phi is equals to phi. That means if you concatenate r with phi, then you will get it as phi. And if phi plus r is nothing but r again. R plus r is r, and r asterisk is equals to r asterisk r is nothing but r plus, and r asterisk whole asterisk is nothing but r asterisk, and also epsilon plus r asterisk is equals to r asterisk. And here there are some more by using, till now we have seen only by using single r, but here we are going to have p, q and r, where p plus q into r is nothing but pr plus qr. P plus q whole asterisk is p asterisk q asterisk whole asterisk, and also you can write it as p asterisk plus q asterisk. So here r asterisk into epsilon plus r, and also if you change it, then you will get it as r asterisk, and r plus epsilon whole asterisk is equals to r asterisk, and epsilon plus r asterisk is r asterisk, and pq whole asterisk p is nothing but p of qp whole asterisk. And the last one is r asterisk r plus r. Then you will get r asterisk r only. Now, by using this identities, you are going to prove some of the regular expression which are given in the question. So, by using these only, we are going to solve the problems. So now the first one is you have to prove this regular expression. That means LHS. If you solve LHS, then you need to get the RHS. Now let us write the given equation. 1 plus 0 0 asterisk 1 plus 1 plus 0 0 asterisk 1 into 0 plus 1 0 asterisk 1 whole asterisk 0 plus 1 0 asterisk 1. So, if you carefully observe, this is one term and this completely is the second term, right? This is one term and this completely is the second term. So now, if you see the identity or if you observe, then you will get it as, here if you write this, if you take 1 plus 0 0 asterisk 1, and from here there is one more term. If you take this term as common, 1 plus 0 0 asterisk 1, if you take it common, then you will be left with nothing here, right? In this term there is no, for the first term you are having only this one, so you are left with nothing, that is epsilon, plus you are left with these two terms, right? 0 plus 1 0 asterisk 1 whole asterisk into 0 plus 1 0 asterisk 1. Now, if you carefully observe, these terms are same, 0 plus 1 0 asterisk 1. For this there is whole asterisk, but for this there is no whole asterisk, which is of the form epsilon plus r into r asterisk, right? What is epsilon plus r into r asterisk? See here, the ninth one, epsilon plus r into r asterisk is nothing but r asterisk. So, which is equals to r asterisk. Now, let us substitute this completely as r asterisk. So, 1 plus 0 0 asterisk 1. This completely as you can write it as r asterisk, right? R is nothing but 0 plus 1 0 asterisk 1 whole asterisk, because it is nothing but r asterisk, right? So, this is completely, you will get it in this format. Now, let us take one common from this. Okay, now let us take one common, then you will be left with nothing here. So it is epsilon plus, if 1 is removed, then you will be remained with 0 0 asterisk This is one term. And for the next thing, there is no 1 here, so we will not remove anything. 0 plus. So from here you took 1 common, so here you are going to write the same thing as it is. Okay. Now let us take 0 asterisk common. Okay. 1 0 asterisk, because in the left RHS side we are going to have 1, we got 1 here. But we are also having 0 asterisk, so let us take 0 asterisk as common. Here epsilon, which is nothing, so no need to write it again. Here if you take 0 asterisk, you are remained with 0 plus here the 0 asterisk, it is removed. So you are left with 1 0 asterisk 1. And also you are having whole asterisk. So which is nothing but the RHS as it is, which we got it here. That means 1 0 asterisk of 0 plus 1 0 asterisk 1 whole asterisk. You can also write it 0 asterisk 1 is also nothing but 1 0 asterisk, right? So therefore we got 0 asterisk 1 of 0 plus 1 0 asterisk 1 whole asterisk. This is the thing which we got by solving the LHS part. So we got the RHS. So now in this way, we are going to use the identities in order to prove the regular expressions. Now, let us prove one more regular expression so that we will be having a good practice. Prove epsilon here. Epsilon plus 1 asterisk of 0 1 1 whole asterisk and 1 asterisk of 0 1 1 whole asterisk. If you carefully observe, this is completely, if you consider R, then this is nothing but R asterisk, right? If you consider this R, this will be completely R asterisk, where R is equals to 1 asterisk of 0 1 1 whole asterisk. See here, this is R and R asterisk will become whole asterisk, right? So it is of the form epsilon plus R asterisk, which is nothing but from the identity you can say it as R asterisk. So from this R is equals to this one. So therefore regular expression of RHS, it becomes 1 star, that is 1 asterisk, and 0 1 1 whole asterisk, which is nothing but the RHS which we got. So in this way you are going to use the identities in order to prove the regular expressions. So these are some of the problems. So you can also use another identities or another formulas which you want in order to prove the regular expressions. Thank you for watching the video.